So we should be live.
Not yet, live yet.
Okay. Okay.
Is it live for you?
Y'all can hear me?
Oh, here it goes, yeah.
All right.
Okay.
Good to go. Okay. So, I should preface this by saying this. What?
The video is delayed by like 30 seconds. So.
Okay. That should be fine, I think, right? So yeah, this is part one of what I hope will be only a part two or a two-part series on distributed applications, otherwise known as DApps, sort of like email. That's what they're calling them now. To begin kind of getting to that end goal of writing code in that environment, we need to first talk about what the blockchain is, or what a blockchain is, and kind of what that represents and how we would use it to, you know, host code. And, you know, I mean, I started digging into this, and it's a lot. So this whole first part, you know, this whole presentation today is essentially like, you know, the cost of entry into what you need to know before you can start talking about distributed applications. Yeah, so I guess I'm going to kind of just go through these slides and let them guide the conversation, but it is a conversation. So if anybody has any questions at any point, please feel free to jump in. I will do my best to answer them. I have way more research than is represented on these slides explicitly, so I can hopefully answer your questions. But again, it is a very large thing, and there's a lot I don't know still. So let's see what happens if I click. Okay, so that's me. When I started digging into this, you know, I have known about Bitcoin for some time. You know, I didn't really fully understand the underpinnings of it, but I had a rough idea. I, you know, came into the knowledge of this thing called Ethereum recently when a friend of mine cashed out a bunch of Ethereum and told me about it. And I was like, you know, what is Ethereum? So Ethereum is kind of what we'll get to, which is like, you know, the way that we can run applications in this type of model. But I decided I wanted to understand this kind of from the ground up. So I started by, you know, digging into the underpinnings, and I suddenly found myself in, you know, reading cryptography white papers, trying to understand monetary systems and like global economics, and like it's a far-reaching, kind of like annoyingly far-reaching thing when you start digging into it. So I will do my best to kind of keep this to what's important, but it's still a lot, and I will hopefully be your guide on this journey down the rabbit hole. So here's the definition of the blockchain, or a blockchain, from the Wikipedia article on blockchain. A blockchain is a growing list of records. Those records are called blocks. They are linked in securities and cryptography. The way they are linked is usually through like a hash pointer as a link to the previous block. And the blocks are time-stamped, and they contain transaction data. Transaction data, you know, is this can be changed basically. When I started digging into like what all this means, I ended up finding that timestamp is really where you want to begin, and so we'll begin there.
So one flat list. Change?
Yes, and as we'll see, I mean, yes, basically, you know, when we get a little further into the presentation, you'll see that there, you know, are actually multiple copies. But for now, let's think of it as just a flat linked list where each node in the list is cryptographically, you know, dependent on the node that comes before. So the main ideas that ended up becoming the blockchain kind of came out of this idea of trusted timestamping. So we look at timestamps all the time, right? I mean, we see like a last modified date in Finder or something if we're looking at a file. We don't really care about that nobody thinks about this, but it is of great importance to certain fields. This is an actual, excerpt of a letter that Isaac Newton sent Gottfried Leibniz. And this was, I don't know if you're familiar with like the calculus controversy, but there's a lot of debate over who invented calculus, right? Was it Isaac Newton or was it Gottfried Leibniz? So while they were corresponding, Newton sent this message with this encoded, basically anagram.
That's true.
Yeah. This when you break it down, like the numbers represent occurrences of, and then this, like when you break it out, becomes a sentence in Latin. And that sentence in Latin directly translates to, given an equation involving any number of fluent quantities to find the fluxions and vice versa, which is sufficient proof that Newton had invented calculus by that point, which he can now, in this letter to Leibniz, he has said, I have it. He hasn't told Leibniz what it is, but now in the future, when, it's disputed who came up with this first, he can say, oh, actually, take 6 A's, 2 C's, and like break it down and say, hey, look, here's a sentence that proves that I had it before you. So intellectual, yeah.
That is so stupid brilliant.
So yeah, intellectual property is like the main, place where this matters, who came up with what first. And that, we don't really think about that, but in like a laboratory environment, that's huge. And so there's also, regulatory compliance, integrity of legal evidence, and finance, which we'll get into a lot more later. But for now, let's talk about this white paper from 1991 by Haber and Stornetta out of a small fractured piece of Bell Labs after the breakup in New Jersey. They released this little red document, how to timestamp a digital document. They proposed that there be a timestamp service. And this was kind of motivated by like an actual problem, that they faced. They were a research laboratory. They had to manually enter ideas on like a daily basis into a paper ledger that was then periodically stamped and notarized. And the stamp would like cover the writing in such a way that basically this is, a record that can't be messed with. And then that was what was used to settle disputes of, ownership of invention, basically. So they wanted a way to do this digitally. And they published this paper saying, hey, what if we had a timestamp service that you could use to kind of create these, timestamps that are real, like these verified timestamps. And it'll spit back a certificate that you can then use against somebody else's certificate to prove in a court of law that this was my idea. So the request response cycle to this timestamp service would go roughly like this. It's 1991, right? So bandwidth is an issue, storage is an issue. Instead of sending the document, say like all right, you're Susie, you write a document, here's how to run a car off of potatoes. And, you write a detailed description of that. Instead of sending that whole, major document to the timestamp service, you send the result of a cryptographic hash function, so you get this hash, you chuck it at the timestamp service. You also give it a unique identifier that says, hey, I'm Susie. And then the service will bundle that hash, your ID, and a timestamp that it has generated. It will then sign that bundle with its digital signature so that it came from the trusted timestamp service. And then we'll return that to you, and that's called a certificate. And you hold on to that file, and say Bob later comes along and writes a paper about how to run a motorcycle on potatoes. You can be like, nah, actually, like I came up with this, as a part of my potato car work. And this way, the timestamp service doesn't have to like keep track of meaning. It doesn't have to actually even store anything in this model. But you have kind of like proof that like this human readable document existed before this other human readable document. Okay, there are problems though with this. So first, I guess this is a diagram of kind of roughly what that looks like. Requester sends a hash of their data, they get back the certificate. Then to verify, you take the hashed document plus the timestamp, you hash that together, and you sign it with the publicly available key of the timestamping authority. Okay, what if the timestamping authority, or service, I guess, the TSS, issues a bad timestamp? Now, that could happen for a variety of reasons, right? Maybe there's a bug in the code. Maybe somebody gets some malicious code on the server. They wanted a solution baked into this. They wanted to kind of secure this from the ground up so that you don't have to trust the timestamp, service, essentially. And they offer two methods for doing this. The first is the linking method. And the idea behind the linking method is that they want to constrain a centralized timestamping service in such a way that even if it wanted to create a bad timestamp, it couldn't. And then the second is distributing that trust. So, you don't have to worry about constraining everything, but basically you rely on collective trust of a group of people to, handle disputes of trust. Like the more people trusting something, the more true it is. So in the linking method, certificates now contain this piece of linking information, which is the LN here. Notice that the N means that we're now considering sequence because the linking information is going to contain information about the certificate that was issued right before the one that you issued, basically. So every certificate now has this chunk in it as well, with the linking information of the previous block also being hashed.
So can I ask a question? So was this part of the solution that was proposed by the timestamp service back in
91? Yeah,
okay.
This is all still 91.
So so what are they linking? It says contains linking information. You're talking about the certificate happened before it.
Yeah. Yes.
So you're basically saying that as part of this timestamp, you're saying this thing happened before this other thing.
Yes. So
you're introducing your implicit, so you can now order these things.
Yeah.
So given two timestamps, you can say this timestamp happened after this time.
Yes, and you can't fake a timestamp because faking one in the future, like forward dating a timestamp, would require depending on blocks that have not yet been issued. And backdating, a timestamp could be easily disproven by, the existing certificates. Now, in the 1991 paper, the way they handled this was kind of primitive, basically, because so you send off your request, it gets processed. When the next person sends their request and it gets processed, the service will send you their unique identifier. So literally what would happen is I get a certificate, you get the next certificate, I get your phone number. And then if we have to go to court, I call you up, you bring your certificate file, I bring my certificate file, and we can prove that one happened before the other. In this particular implementation, you notice this is N-1. Tracing events back through time means that each event is dependent on the one immediately before it. And so that's, kind of not ideal. If anybody loses their certificate in the chain, it kind of makes verifying everything in the past and everything in the future. Yeah. So their solution for that was make it longer. Basically, instead of now I get your phone number, and it processes 10 more requests, right? And now I get 10 phone numbers. So, and it's processing them kind of in blocks. And so every time you hit, you start a new block or whatever, everybody in the previous block gets the identification information sent back to them so that they can contact the certificate holders within their block. Okay, and that also makes it much harder to fake because now we're talking about a k-wise hash collision, which is a pairwise hash collision is already basically impossible or very hard.
So you would have to, in order to fake that, if you had a conspiracy with the 10 people in your block,
right?
You could
yeah,
you could fake something.
Basically, yeah, and I think I think so. Yes. Yeah, I think that is the case. And basically, the main observation of this linking method is that as the length of this chain, or as the length of this number of people in your chunk increases, the difficulty of faking an event becomes increasingly impossible because you'd have to collude with a larger number of people. And additionally, you have to collude with the centralized timestamp service itself, which signs everything. So good enough, right, for most applications. And that's roughly what that ends up looking like. Oh, okay. So you like UPS packages, not lunch. This actually, this method, as well as the next method we'll discuss, actually, has been used for a long time. And kind of the newspaper chunk right here is that for certain applications, like I'm not sure exactly what, but things involving like finance, you could see in like, a financial newspaper at the top, they would publish like a hash of the current node in this linking tree or whatever. So yeah, you can find newspapers with that on it, from like the 90s and early 2000s. The other method that was proposed in the paper was distributing the trust. When the client requests a timestamp, they do so from a random collection or random selection of, all of the peers in the system, and they all issue their timestamps and they all sign their certificates. And so you would need, basically like large levels of collusion to fake something. And then also this removes the need for like a central authority because everybody's doing the timestamping. And so the takeaway here is that trust based on consensus is more reliable than trust based on a single authority. What the paper didn't do was combine these things. And that's sort of what the blockchain does. Instead of having they offered basically either we have this central authority that cannot fake timestamps, or we have a distributed authority that all they're doing is signing the certificate. So, they can all fake timestamps, but they'd all have to fake the same timestamp. In the blockchain model, we have everybody keeps a copy of that linked list. And the consensus...
Entire linked list.
No, but for the sake of the argument, let's say yes. Like it's optimized in some ways that I really don't want to waste time going into like Merkle trees and shit. So like you have a copy of the chain, and then we'll get into it more later.
So
but basically,
have a copy of the chain that only goes back like a certain amount, or is it more complicated than that?
So yeah,
Okay.
it is more complicated than that, and we'll get into it when we start talking about Bitcoin.
Could you retrieve the chain if you wanted, if you so chose?
Yeah, the entire chain is public. You can even go to, forget what the website is, but there is a website you can go to and view the blockchain from the very beginning, like from the first minting of Bitcoin to now, and all of the transactions that were in that chain. If you ever feel so inclined. But yeah, the entire the entire lineage of coins in the case of Bitcoin is public, and each peer doesn't necessarily hold like a full copy. In fact, I don't know that any peer holds a full copy, but you hold like a chunk of the copy, and then the part of this that matters is the longest chain, in any given dispute. Like if a block in the chain is called into question, somebody with a chain that contains that block, the person with the longest chain containing that block is considered the authority, right? And so that's how these two things are combined. And we'll kind of get more into that down the road here. So Bitcoin was the first kind of implementation of what we call a blockchain. There were stabs at it before this. There were a couple almost there things immediately leading up to it, but basically Bitcoin came up with the blockchain as a means to an end, kind of like Newton coming up with calculus to get to like a better understanding of physics. Bitcoin from the get-go was intended to solve a lot of problems with finance and the way money is transferred kind of at a global scale. But to do so, it also came up with the blockchain. And so talking about one, we really have to talk about the other. The Bitcoin white paper was published in 2008 by a person named Satoshi Nakamoto, which is not a real name. The author of the white paper is still unknown, probably because some of the people who came up with things like this are in jail, because countries generally have some type of law where you're not allowed to print your own money in them. And yeah, so anyway, we don't really know who made it even now. So let's talk about money a little bit to understand kind of like what Bitcoin was trying to address. Does anybody here know the difference between a commodity-backed currency and a fiat currency?
No.
Okay.
One is locked into a physical standard, right?
It's like the gold standard.
Yeah.
Yes.
Yeah.
Yes, it's exactly like the gold standard. And this is where some of the tinfoil hat aspects of this community come into play. If you ever wonder why, when you watch Fox News, if you watch Fox News, I do, I find it funny.
Lots of ads for gold.
Yeah, there's lots of ads for gold. And a lot of people, seem to think that returning to a gold standard is a good idea. But really, I think that demonstrates a naivety about what these things are. The truth of the matter is fiat currency is based on nothing, and that scares people. But it's based on nothing for a reason. So let's talk a little bit kind of about the history of I guess specifically the gold standard. So right. All right. So some advantages of a commodity-backed currency, which, I mean, let's just call a gold standard currency, is that in the long term, it's stable. Inflation in the grand sense is extremely rare. Inflation in small increments is very common. Like there's rapid little spikes, but over the long term, you don't have inflation the way that we know it now, because the money supply can only grow at the rate that like a gold reserve increases. There's also fixed exchange rates. If two countries are engaged in trade and they both adhere to this standard, then there's one source of truth when it comes to valuation. And also it's real, which counts for something. Every banknote can be turned into a unit of tangible something. And that kind of,
kick the can down the road, because ultimately what people the value of gold is what people are willing to exchange for it.
Yeah.
And I mean, is it the shininess of it, or the it's thermal conductivity? Like, how do people rate gold?
It's a very good point. Both of these systems are essentially based on nothing. It's just that in a gold standard system, there's like one more level of nothing. Yeah, like there's a level of abstraction between.
Yeah, it's like, what if we decide gold is worthless?
Right.
Yeah. No, which we totally could.
Yeah.
So, I don't want to get too existential,
Right.
you know what I mean? Right. But you're right. Like it's just a level of abstraction that is there, that is absent with fiat currencies. Some major disadvantages of this system is the short-term instability, which I mentioned. Like if there's a gold rush, and suddenly there's more gold, then you're going to have inflation randomly, but like at a much larger scale than you would have it now. And then, it'll just spike and come back down. Like it might not match the price of commodity goods. There's a lot of problems that are introduced with that. And in fact, we found that it's better to have a constant rate of inflation, but have that rate be like predictable and low, for reasons that I really don't want to bother getting into. Also, under a commodity system, you're vulnerable to speculation attacks, which I think I can also skip going into the gory details of. But basically, you could conceivably, like, this speculation is part of why we had the Great Depression. If a bunch of people suddenly go to the central bank of the country and they're like, I don't want this banknote, give me my gold, That's called a run. So, a run on the pound during the Great Depression from investors in New York and Paris tanked. They were like, we can't do it. We don't have enough gold. So they had to go off the gold standard, and eventually that's kind of how everybody got off the gold standard. The gold standard is rigid. It's impossible to move large sums of money quickly, and the situation in which that kind of came to a breaking point was World War I, the Great Depression, World War II. We had to rebuild entire nations that we destroyed, and we found that if we're stuck with we only have as much money as we have gold reserves, we can't really rebuild Germany, because Germany doesn't have any money and we don't have enough to give to them really. So yeah, basically, World War I, World War II, the Depression, these things moved us kind of towards being off the gold standard. And then eventually, the US has officially denied any convertibility of US banknotes to gold in 1971. It was Nixon, the Nixon shock. So that's, since then, what we've had is this system of floating value fiat money for every Western nation, and then by, kind of forced extension, every non-Western nation. A fiat currency, is the value of it is set by a government, and that's it. We have the ability, as a result of that, to kind of mess with it. You have a little bit more control over your economy. You can inject money into the economy to control inflation. This is kind of the core of Keynesian economics as far as monetary policy. Some of this is probably not super relevant as we get further in, but basically, the system that we're on now is a fiat currency. It's also super necessary for international trade. The idea of going back to a commodity-backed currency as we used to know it is ludicrous, and y'all should know that, because people will scream at you as you if you kind of get the more I got into this Bitcoin quote unquote community, everybody is real up in arms about fiat money, and there are problems with it, but going back to a gold standard is just really dumb. And I'm not
advocate is the gold standard.
Well, what you'll come to find is that Bitcoin is kind of a newer version of the gold standard. There's a finite amount of Bitcoin, and they are mined. And so it seeks to address some of the problems with a commodity-backed currency, but I mean, I suspect it will also have a lot of the same problems and also new problems. But that's just my opinion. And I don't want to get super far into the economic side of this. You should know that some of, if you go on YouTube and you look up a video about Bitcoin, you will likely, at some point, somebody will be yelling at you about how governments are awful and they're exploiting money to it's colonialism and people are dying and sometimes they'll even cry, and the people who are often into this, deeply into this stuff are staunch libertarians. And I don't want to get super, into politics of it, but just you should be aware that, the more you research this, the more likely you are to bump up against somebody screaming at you about gold and crypto gold and fiat money. And it's important to know what they're screaming about. And I encourage you to do your own research. I did a lot about this, and I'm pretty convinced that a lot of it is phooey, as they say. Anyway, so yeah, a cryptocurrency is kind of a new entry here. It is a commodity-backed currency, but not in the traditional sense, and that's what's exciting about it. So why Bitcoin? Why? Why does this exist? I learned about Bitcoin in, let's see, early 2011, late 2010. At the time, it was worth 79 cents a coin. I kick myself every day that I didn't buy, coins at that time, because now they're worth $2,400. Why? Why is that? At the time that I found out about it was that's interesting. It'll never work. Drugs are the reason. drugs are the reason that Bitcoin caught on. Like there's no way around that, and it's kind of an ugly fact and something that I think hopefully will be moved past. But Bitcoin allows you to send money very quickly and somewhat anonymously anywhere in the world. For people sending drugs through the mail, their previous options included Western Union under a fake name, MoneyGram, rechargeable money packer. Like all of these things had like high fees and also like a paper trail. And Bitcoin had basically no fees and no paper trail. And that, made it instantly like the currency of choice for the black market. In 2000, this is a timeline that I actually just screenshotted right out of my notes because I was lazy. So in 2008, the paper's published. In 2009, the first implementation of it appears. It's open sourced. They mint the first block of coins, 50 coins, which is worth some ridiculous sum of money now. When the Silk Road, which is like the first kind of major crypto dark market, goes live, a Bitcoin is about equal to $1.
That's a guy from Austin.
Yeah.
He was?
Yeah.
Oh.
Yeah.
Ross Ulbricht, is that right? Yeah. Or was that the? Oh, that's crazy. I didn't know he went to ET. So yeah, and I guess it's also worth noting that like this has been going on since way before this, or way before this particular, the Silk Road came about, and it was done kind of like very quietly in these small communities, and this kind of was a big deal because it said, hey, come publicly buy drugs from us. The cryptography, side of it allowed them to just do this wide out in the open. And that was kind of horrifying and unheard of. So, when they go online, it's about $1. And then within a few months of that, there's like mainstream articles. Gawker was the first, but then eventually, there was a New York Times article about the Silk Road. And their contention was, you can't get to us. And we want this to be like in your face, governments. And so it was kind of, a political statement as much as it was a huge money funnel. So anyway, after that gets published, we spike from $9 to $30. By the time they're seized about a year later, we're now at $130. A month later, 641. This is when the U.S. Senate holds its first hearing on Bitcoin. And then 2 days later, 1132, when the People's Bank of China publicly approves the use of Bitcoin. So like basically the black market drove the popularity of this, and without it, we wouldn't have it. Worth noting.
What's your understanding, you might get to this, of like how liquid they are?
How liquid they are.
In terms of like, if I had 5 Bitcoins right now and I wanted to offload them and get US dollars back, like how difficult?
Easy.
Pretty
Easy.
Yeah.
For 5, easy. Like it's because there is no central banking authority, because the validity of transactions is tracked through the blockchain trust method. Whereas in traditional finance, you depend on a bank, with like a centralized kind of source of truth. Because of that, you actually sell them for US dollars to another person. Like, it's not like you go cash them into some entity. There are Bitcoin exchanges, and the exchanges essentially connect people who want to buy Bitcoin with people who want to sell Bitcoin for various currencies. And that's how that works. So Coinbase is the biggest one right now, and you could go on there and buy 5 Bitcoin, pretty instantly. And you can sell 5 Bitcoin pretty instantly. So trading Bitcoin is, kind of a big thing, and people make a lot of money doing it. But it's an extremely volatile market even now. Anyway, that was probably deeper than we needed to go into the economic side of it, but let's kind of talk more now about the blockchain implementation proposed by the original white paper. So this is the abstract of the original white paper. The problem that it was kind of seeking to solve was, finance at a global scale, and, basically validating validating that in a way that didn't involve a central bank. Like when you send a transaction, like a bank wire, from your bank account to somebody else's bank account, it takes days. When you get a direct deposit check, even, it takes days to clear. And it's because like all of this validation is kind of done, using very old school methods, and by like a single place. So this wanted to kind of solve that issue. And then even though it's not directly stated, like part of the motivation for doing this was kind of to subvert the global economy as we know it. So this should look familiar based on the timestamping document we already talked about. In this system, we're thinking about coins as kind of transactions of value, right? In order for like you can think of, these transactions as items in a ledger, a global ledger that is publicly accessible, basically. When you transfer money to somebody else, you both kind of sign the transaction to verify, that, hey, this did actually happen and we're okay with it. And then they are linked together in the way we described, so that they kind of become dependent on each other in time. And the timestamp server then just becomes blocks of these transactions linked together by their hashes. So the way that this differs, or the way that this like can begin to differ from what we already talked about, was this concept of a proof of work. So Bitcoin is a currency. You need a way to mine currency, and you need that to be mapped to something. In a gold-based currency, that the value is mapped to gold. In Bitcoin, the value is mapped to computational work. And so basically, each block in the blockchain is a ledger of these transactions that you've signed, and broadcast out to the public. Everybody who is on the network like listens to these transactions, puts them in blocks, and then tries to add a chunk of data at the end here that, when hashed, will result in something with X amount of leading zeros, basically. So this is a little complicated, I guess. Let me, not 100% sure how to explain this. In order to mine blocks, you are constantly sending hashes out into the network, right? And this number of zeros required to like mint new coins is constantly changing. And that's the mechanism by which inflation is kind of controlled. But we don't really need to get into that, I guess. The point is, a block is made up of entries in a ledger, and then a chunk of data that validates to the currently expected number of 0 bits in a SHA-256 hash. When that happens, the block is, created, essentially. You are minted 10 new coins as a reward for doing the CPU work required in like crunching those numbers until you hit the correct hash. And that block is then broadcast to the network. So that was, I did a poor job explaining that. Do you have any questions about kind of like how that process works? I will try to answer them if you do.
I could probably ask 1,000 questions about it, but
Okay.
I think you did a pretty good job.
Okay, so yeah, the proof of work is the critical element here, basically, because this now means that like this represents the value. Somebody sat there and did X amount of CPU cycles or GPU cycles to like prove this. And once that's done, anybody, trying to fake this, not only would they have to like basically that's the piece that links each block to the next. So it's not, in the linking model that we talked about before, anybody trying to fake a block in the history would have to like calculate, a hash collision, right? X number of times into the future. In this, they would have to calculate like a hash collision that, the hash is like something that took a lot of CPU intensity to get to. So not only would they have to like rely on the collision of multiple hashes, but they would have to do all of the work for every block preceding it in the chain. That's why that's important. It also provides an incentive, right? Because if you mine a block successfully, you get, like, you mint new coins and you get them. And so for, it's no longer really feasible now, but like for a long time, you could just basically have your GPU crunch hashes all day and just make Bitcoin out of that. And that was kind of part of what attracted people to it to begin with. So that chain, is sent out to basically everybody listening on the network. If you're not listening, when you come back online and you want to see, hey, what's happened since I've been gone, you get, you reach out to a bunch of peers and you kind of like get the chain that is longest, which again is relying on that idea that, like, as that number grows, it becomes more trustable. When a conflict needs to be resolved, like if two peers have a slightly different blockchain, the peer with the longer blockchain, the truth, basically. So here's kind of like a breakdown of everything we just went through with less diagrams and maybe a little bit better of an explanation than I gave. New transactions are broadcast to everybody listening, which is everybody running the Bitcoin program. It's, sitting as a daemon listening for new transactions. Every node collects new transactions into a block. Each node works on finding a difficult proof of work for its block. When that is found, it broadcasts it to all the blocks. And then if all the transactions in it are valid, the block is accepted. And then I guess, yeah, the acceptance of that block is expressed by kind of like creating the next block in the chain using the hash of the block that was just received. It's a chain of blocks. It's a chain of blocks. Really, like, all of this is leading to, it's a chain of blocks. So this is a block in the blockchain, right? And this is, what Bitcoin looks like. These graphics were shamelessly stolen also from a YouTube video, so I should throw some attribution up at some point. But what we're really driving at here, and what I want to get to in the next kind of section of this presentation, is what happens when you put other things in that. What happens when that's no longer a simple list of transactions, Susie paid Bob, Bob paid Joe, et cetera. And what if it's code? Or what if it's anything? The point is that, like, the blockchain, this method of, like, cryptographically secure distributed trust undermines a lot of stuff, and we can do a lot with it. And Bitcoin was really just like the first thing to come out with it. Ethereum was a company, that when they were kind of like starting, they started based on the premise that they knew this applied to other things, but they didn't know what yet. And it was not until like several years in that they started realizing, we can use this to run code on what is essentially a global computer. So that's what I'm really interested in, and that's, like, as software developers, like, that's what, that's the more interesting part to us. How do we, leverage this to write truly distributed applications? How do we make the Internet of Things an internet, like, of things, if so to speak? And it's a hard way to put it, but instead of, the Internet of Things as we think about it now still relies on centralized trust in many ways. And this is something we touched on in the podcast too. If we can leverage this type of technology, we no longer, we can break that basically. And it won't be like, things connected to the internet. The things will be the internet. And that's the exciting part. So yeah, that's all I got for this part, basically. Hopefully that lays the groundwork for, like, in the next presentation, I'd like to actually write a program and run it on the blockchain. I think that would be cool. Oh, man. I should have slept more last night. So, yeah.
Awesome.
Glad to hear it, yeah. it's a really high bar for entry before we get to like,
Yeah.
you know, but I would definitely recommend, you know, it's worth a day or more of your time to just read about it and read about what it is and how it works, because Bitcoin is one thing, but like the blockchain itself is here to stay. Like you sent me that article that NASDAQ is looking into, you know, applications for it, right?
Yeah.
I mean, it can apply to a lot of things outside of money, you know?
Yeah, well, I've seen there's a lot of just looking around at who's investing in this right now. And I notice a lot of people at IBM are talking about blockchain and they're investing in it too. SAP and all these sort of big global tech companies are all putting money into it. I think they don't know what to expect from the other side, but they're all tinkering with it right now.
Yeah. Yeah, I think it's pretty safe. It's pretty safe to say that it's here to stay in a lot of respects. You know, Bitcoin may not be, but like just this general concept certainly will be. And I mentioned earlier in the presentation that like the US Senate held like a kind of an open panel on this shortly after the Silk Road was closed. And there were, you know, everybody was expecting it to be like, this is a menace, and you know, our kids are gonna be doing drugs and buying guns and all kinds of stuff. And in fact, the hearing was actually very positive. And you know, that's been the case kind of across the board. Like very few governments have come out directly against it. I don't know of any other than China. I'm sure there's others, but like very few have come out for it.
Mm-hmm.
But you know, almost nobody has come out and said, hey, this is full on illegal, and if you use it, we're going to send you to jail. And I think part of that is because it's, you know, people recognize that there's not really any stopping it. You know, the idea is out there. And
yeah. One thing I heard that resonated with me pretty well was that the reason why people feel like this is like actually here to stay, or part of the reason is that money still moves pretty slowly across borders. And we kind of like take for granted that like everything on the internet happens super fast, but like actual conducting international transactions and getting that money to hit your bank account still takes a couple days. And with this kind of framework, it's very instantaneous. So deals can start happening a lot faster. And they feel like that's like part of the kind of like top-down adoption.
Yep.
That's going to lead to more people and companies, and then, you know, make its way into just kind of like everyday commerce.
That's absolutely true. Yeah, I mean that's part of what motivated it as a tool for black market transactions. You know, if I wanted to buy acid from Poland, I had to send to Western Union. You know,
Yeah.
and that there's a fee, and it takes days to get there. You know, but I mean the same thing applies to regular commerce. It's just that, you know, it took that kind of like dirty part of Bitcoin's history to like get it big enough that now we're realizing, you know, when a transaction is sent, you know, from here to South Africa or whatever, all that has to happen is like X amount of peers, you know, hear the transaction and validate it. And you can actually go, yeah, it's blockchain.info. Now I remember blockchain.info is where you can kind of like watch the real-time movement of these things. And you can, you know, when you make, you know, a Bitcoin transaction, you can see like it being validated by peers on the network, you know, and it's, I don't know, it's not instant anymore. Like when it first started, it was like that. Now it takes about 2 hours, but compared to, you know, current banking systems, 2 hours is instant, you know, to send money like across the globe. So, yeah, and that's actually why the hard fork happened, is because the fees are getting too high and the time is getting too long. So they wanted to, like, you know, address that. But we don't have to go into all that. Yeah. So anyway, next time we'll actually do some coding, and hopefully this will be more relevant to our interests. Yeah. Sorry for the extreme amount of background information, but I feel that, you know, it's necessary to get to something cool.
Yeah. Thanks for putting that together. Do you have any questions from the field?
No, we did not.
Cool. All right. All right. Yeah. I'm going to end the broadcast. Thank you, anybody who was watching on YouTube, and have a good rest of your day.